Welcome back to our channel. Nice to meet you guys. Okay, question number 5 is a long question with A, B, 1, 2, 3. Just calculate them one by one. So look at the question first. A, okay. Write down the equation of the horizontal asymptote. It give you the graphs, okay? So how to find the horizontal asymptote? Look at the function. Function is here. Horizontal asymptote means that x tends to plus or minus infinite. You know how to solve it. Okay, we know when this happens, 1 over x will tend to 0. So we have to make some 1 over x and set it to 0, and that's it. Okay, so change the function. Okay, change the function to take out the x, so become 2x 1 plus v over x over vx 1 plus 2 over x. And then the x cancel out, and this 2 becomes 0, and x tends to inverse, so become 2 times 1, v times 1, so becomes a v over 2 over v. So the horizontal asymptote will be y equals 2 over v. So that's the result of A. And B one, okay, write down. Write down means just observation. Okay, we use a straight line to show you. It said that we have another function gx equals mx plus 1, so it is a straight line passing through the y-intercept 1. So here, okay, it said that if m is larger than 0, it means a positive gradient graph. Okay, write down the number of solution of f equals g. It means the number of point of intersection between the straight line and the curve. Remember, positive gradient, right? So it must have how many point of intersection? 1 here, right? 2. So it must have 2 point of intersection. So for this one, you need to just do the observation is okay, because it said that write down. So the answer for B1 is 2. And that's it. And for B2 and B3, it is determined. Determine the value of m such that f equals g has only one solution. And 3, determine the range of values of m such that fx and gx has 2 solutions for x larger than or equal to 0. So for these 2 is a determined algebra. So we can forget about the graph. Really, just work on the algebra and then you will know the result. Okay, we start on B2. Okay, B2 said that the solution. So we have to solve f equals g, right? Explicitly, really write them down. Okay, so 2x plus 3 over 3x plus 2 equals mx plus 1. And then move the thing up for multiplication and then expand them. So the left hand side we have 2x plus 6. Remember, easy to have a careless mistake. Really be careful. And this one multiplied is 3mx squared plus how many x? Okay. 3x, 3, okay, 3x, 2, 3, 6 times m, okay, so plus 6mx, and then 3, 2, 6 times 1 plus 6, okay. So we do it slowly in this way, and then you will find out the 6 cancel out, and you move the 2x to the right hand side, become minus 2x, so 3 minus 2 become 1. So the equation become 3mx squared plus 1 plus 6mx equals 0. Be careful, don't cancel the x. Okay, take the x out. Okay, x 3mx plus 1 plus 6m equals 0. So we got all the 2 solutions, exact solution. So x equals 0, or x equals, move it to the right hand side, minus 1 minus 6m over Vm. Okay, this is the result. So look at B2. Determine the values of m such that it has only one solution of x. We have one already, right? But we have another solution, okay? Then how can we have one solution? Double solution, double root. So this solution is also 0. So for B2, we set this to 0. It means that minus 1 minus 6m is 0. So m equals negative 1 over 6. That's the result of B2. Okay, so for B3 is even more complicated. Determine the range of values of m such that the solution is x is larger than or equal to 0. We got one solution already. It's a two solution. So the second solution has to be larger than or equal to 0 too, okay? So you have to find out this thing, larger than or equal to 0. So for B3, we continue our journey. We start from the result of B2. So for B3, we need to set this thing, x equals this thing, larger than or equal to 0. So we have to consider two scenarios because m is never 0. You have to consider m larger than 0 or m smaller than 0. See which one works. Okay, so consider m larger than 0. So this is larger than 0. Move to the right hand side, no change. Okay, so minus 1 minus 6m is larger than or equal to 0. And then move this to, so negative 1 larger than or equal to 6m. So m is smaller than negative 1 over 6. Contradiction. You say m is larger than 0. So contradiction, so this one is rejected or impossible. Okay. So we consider another possibility, m less than 0. So move this m to the right hand side. The inequality sign had to change. Okay, swap. Okay, so it becomes minus 1 minus 6m smaller than or larger than 0. And then move this. So 6m is larger than or equal to negative 1. So m is larger than or equal to negative 1 over 6. Oh, bingo! So you got it. But should we include the equal sign? But it has set two solutions. So one is 0 and the other should be larger than 0. So, sorry, I made the mistake. So all these things should be larger than. Sometimes, some reflection, you need it too during examination. So what is the range? Okay, less than 0, but larger than this one. So you say, so the range is larger than negative 1 over 6, but smaller than 0. This is the possible range. So this question is hard. Although part A and part B1 is straightforward, B2 and B3 is difficult. Look at the questioning word, write down the graph help you, write down maybe straightforward, but determined are not of steps, okay? Sometimes it's algebra, so maybe you can get the graph, okay? You got it? Well done.